Where's the button?
We're rolling.
We are rolling. All right.
Go for it.
Well, good evening, folks. Thanks for being here for the April meeting of the St. Louis Java User Group. Our planned speaker for this month had to reschedule, and we had to kind of to pull things together last minute. And Billy Korando from Oracle was gracious to drive all the way from Kansas City, correct?
That's correct.
To join us. So we really appreciate that. Pizza provided by OCI, my employer, and folks that are hosting us here in their training room. I'll blow through these slides here real quick. I'm not going to give all the history that Bruce does. You guys know who we are by this point. We do have a meeting in planned for May, correct, Bruce?
Assuming we can get an MC.
It is. All right. So Java User Group has a steering committee, which is mostly folks who don't live in St. Louis, except for me. So if anyone is interested in helping out and being a little more involved in the JUG, we would definitely appreciate that. It is important to have good local presence here. Just talk to me in this case if anyone is interested in getting more involved, or even if not in the steering committee, maybe you want to help out some other way. Maybe you know of a good speaker, maybe you have an idea for a presentation or something. So talk to me. Send Bruce an email. Our email list is there at the bottom of the slide, and I can share that with you if you will get a chance to write it down. Thank you to our sponsors, OCI, again, my employer, the folks that host us here in the training room, Manning, JetBrains, who have been longtime partners, and Lee Bobbitt, who's usually often attends with us, is covering our Meetup subscription. We appreciate that. Kansas City Developers Conference. Are you involved in that?
Yes.
Yes. Maybe you'll plug that a bit too. It's September, and I get is registration already open?
Yeah, so you can already buy tickets. We're going to be announcing speakers pretty soon, and when we do that, that's when super early bird pricing ends. So take advantage.
So right now you get the mystery discount. Yeah, you don't know who's going to be there, but
you know it's going to be great.
It's going to be great. Absolutely. All right, that's cool. And then we have our long-standing Manning discount code. So thank you to Manning Publishers for that. There we go. So May 14th, Jim Kaklik is going to be bringing us a presentation on software quality. And then we have a meeting scheduled in July as well. Looks like we had to fill out June still, so we still got an opening for another speaker. All right, and you can check out the Meetup page, of course, for updates on upcoming presentations, other things that we might have to notify through that. And then we do have a YouTube channel where you can view past presentations. And as I said before, get a hold of us if you're interested in giving a presentation, or you know someone who might be a good speaker, please let us know. And with that, tonight's presentation, Java is Data by Billy Korando. I will let you take it away, Billy.
Sounds great. All right, thank you, Zach, and thank you to Bruce and Ted and everyone on the Gateway, or the St. Louis Java Meetup community for giving me the opportunity to present. And yeah, fortunate the circumstances because Pratik, he's a good friend of mine. I actually used to work with him when we were both at IBM, which coincidentally we were also laid off from. So unfortunately, a lot of that going around in the industry. But you know what? Let's talk about positive stuff, about a new paradigm emerging in Java, about how Java can be used in data-oriented programming. So my name, as mentioned, is Billy Korando. I work for this small company called Oracle as a Java developer advocate. But don't hold that against me. I'm otherwise an okay person. Important information. Please, at any point, feel free to ask questions. After all, I'm here for you to learn about how to do data-oriented programming in Java. Let's see. It's not me. I think, Bruce, you might be over the, hold on. Or something. Okay, I think that's you. So
that's mine. Let me get this out of the way. Yep.
There we go. Perfect.
There we go.
Awesome. All right. And also, if you want to link to this presentation,
yeah, they'll do that.
And if you want to link to this presentation, you can just go to www.korando.github.io presentations Java-DOP. This is where you can see I am running from right now. And I'll also make sure to get all the slides of this sent and shared to Bruce so you can put it into the Meetup meeting. If you would like to know more, there's a lot of great places to go to. So the team I'm on at Oracle, we run a few different sites and locations. There's dev.java, where we have a bunch of tutorials and things like that on, for example, how to do data-oriented programming, along with a lot of other Java features that I'll be going over, or language features I'll be going over during this presentation. You can also find out where all of the various JUGs are located at. So, for example, I also run the Kansas City Java Users Group over in, obviously, Kansas City. Not too far from here is also the Chicago Java Users Group. So there's a bunch around here. There's also Insight.java. That's a good place to go to kind of follow what's happening within the development of the JDK. And we also have our YouTube channel where we're posting multiple videos a week. As I was mentioning a little bit before this presentation, we just recently did the Java 1 conference back in middle of March, and we'll be posting 2 or 3 videos from that presentation a week over the next several months. So if you want to kind of see all we had at Java 1, you can check it out there. Lots of great presentations from people far smarter than me. All right, so agenda. First, we're going to, of course, go over what is data-oriented programming, or DOP, D-O-P. What are the language features? What does it look like to define or design a system that takes advantage of data-oriented programming? Also a little bit of when to use it, practical uses of DOP, and then also what the future of this looks like in Java. So yeah, the first question is, what is data-oriented programming? And before we go through that, let's just quickly review what is object-oriented programming. Of course, something we're all, at least I imagine, somewhat pretty familiar with, but let's just quickly recover that. So it's modeling entities and processes through combinations of state and behavior. And so like a very simple example of that is, like, let's just say I am building out a kind of application that handles conferences, which of course is something that I'm very familiar with, being a developer relations person and going to a lot of presentations or a lot of conferences. And so maybe we would have some sort of class like attendee that kind of exists at the very top, and it's going to have like things like first name, last name, company, email, and maybe any of the presentations I would like to attend at a conference. But then, I may have a couple of things like methods for like adding and removing a presentation, maybe validating if an email is correct. And then from there, I might then extend off of that attendee class with maybe something like a workshop attendee. And it too could also have some classes for updating its internal state, or also doing some things like some businesses, like business processing, like, is it valid for me to add this workshop? Maybe it would check to make sure I don't have like another workshop I signed up for at a conflicting time, or maybe that workshop is already completely full, so I can't add to it. But the point is that one of the things with object-oriented programming is that you would have maybe business processes happening within the entities on it. So yeah, mutable state, you use a lot of things like abstraction and a lot of things like inheritance. And of course, this presentation isn't about saying, don't use object-oriented programming, only use data-oriented programming. By no means. It's just mostly that understanding the differences between the two. So then that is object-oriented programming. What is data-oriented programming? It's defining a system by immutable data that is then acted upon by other operations. So the defining characteristics of it would be, again, modeling data immutably and transparently, just only focusing on the data and not trying to define anything else outside of it. Another really key thing would be making sure that illegal states are unrepresentable, and then also having a clear separation between operations from the data. These wouldn't necessarily be hard and fast rules, or hard rules, or universal rules. And a lot of this I took from one of my colleagues on the Java DevRel team, where Nikolai Parlog, he put together this article that was kind of expanding upon something that Brian Getz, that's the chief language architect at Oracle, he wrote. So he just maybe expanded upon it a little bit and also made it a little bit more practical and consumable for Java developers. That said, DOP isn't new. Like so many things in computer science, it usually goes back to either the 80s, 70s, or 60s. In this case, the 70s. I can't remember on his name. Yes, Philip Walder. He was a Scottish data scientist. He defined what's called the expression problem, which is a distinction between abstract data types and objects. And so basically the expression problem is that when you're not the owner of the code, you have either two options. You can either have polymorphism, where you can add new subtypes, but you can't add new operations. So you can extend upon maybe some sort of objects, but because some of that representation of those objects might be held higher up, you can't really add operations to it because you wouldn't have the full state of that object available to you. Alternatively, you can have pattern matching, where you could have operations to it because you would have the full view of that the internal state, but you can't add new subtypes because it's no longer extendable. And it'll make a little bit more sense here in maybe a few moments. So you probably haven't heard about data-oriented programming, or you're probably, for many of us, you've probably been doing Java for a number of years based upon what I can tell from the age of people here. It's a relatively new thing. The first and central enabling feature adopt is records, and these were added in Java 16, which was added or released in March of 2021. And this allows for the transparent of modeling data as data. So here is a simple example of like an extendee, and we would be, having maybe fields like first name, last name, and company. So records, they have a number of constraints on them. They can't be extended. You can't define instance fields within them. All the fields are final, and a canonical constructor must be invoked on initialization. And this kind of, again, helps to make this data transparent. You would be able to have access to all these fields because one of the things that comes with a record is that it already grants you accessors to all those fields. It also, as I mentioned, needs to call the canonical constructor on initialization. So the canonical constructor would be a constructor that initializes all the fields within a record. So you can helps with the making data in legal states non-representable. Another one is that also by making it final, that prevents that keeps the fields immutable. So they're not going to change on you once they've been set. Of course, it's sadly immutable, but I'll get into that maybe a little bit later. Another key enabling feature is sealed hierarchies, or also called sealed classes. These were added in Java 17. And what this allows is a class to define which classes are allowed to extend it. So let's just say I have an interface called conference attendee, and I permit it to only standard attendee, workshop attendee, and speaker are the only classes that are allowed to implement, in this case, an interface. And this allows it to be a sum type. That means that it can find all other possible things it can be. And so, no other class can extend or implement this interface. And then finally, pattern matching. This are several case examples or different language features of this being implemented. The first being instance of, which was added in Java 16, then pattern matching for switch and record pattern matching were both added in Java 21, and then finally unnamed patterns of variables were added in Java 22. So pattern matching with switch and records. So it allows you here in this example where you're switching on this attendee, conference attendee, which again we define back up here. And if it doesn't match on it, then we can reference fields from this attendee in the body of that matching switch. But because we also define this switch hierarchy where only standard attendee, workshop attendee, and speaker, these are the only ones that can extend off of it. Typically, a pattern matching for switch would need to be exhaustive, which would often mean you would need a default case. But because I'm defining all the cases in that sealed hierarchy, I don't need a default case here. And one of the benefits here is if I was to later add another attendee to that sealed hierarchy, I would actually get a compiler error here because this is no longer exhaustive. So the helpful part of this is that it can help prevent bugs from getting in production, where you can add some new feature to it and maybe didn't necessarily cover all the cases throughout your code base. So that is a very nice benefit of how this can be safer when working on the applications. You can also do record patterns with pattern matching for switch. So with pattern matching, you can then have a deconstructor on that record where you can extract all the state of that record. And then also here, these underscores is using the new unnamed pattern matching, where you can replace a variable that you may not be actually needing to reference with an underscore. In this case, all I care about is like the first name, last name, company, and profile picture, because I'm building out like a speaker page for my conference application. And so instead of having to unnecessarily define a number of variables, so back up here, you can see that for like the speaker record, I have like a few other fields like favorited presentation, workshops I'm maybe signed up for, and maybe all the presentations I'm giving. In this area, I don't necessarily need those. So I can replace that with an underscore, and that makes it a lot more clear to yourself either in the future or to other Java developers or other developers working on this application in the future that you don't care about these fields. So just a bit more clarity in the intent of your application. All right, so these are the features that allow you to design a Java system, but what does that actually kind of look like? So again, you want to model your data transparently, so you don't want to hide state, and you want to have allow operations have a full view to the data they are acting upon. So records already provide this naturally. Again, so if I just define a record, I don't have to do anything more to follow the modeling data transparently principle. That if for some reason maybe a record doesn't quite match what you're looking for, and you still want to use a quote-unquote normal class in Java, you can still follow that. It's not like it's only allowed through records, but you would just need to follow a lot of the principles of making sure you have accessors to all of the fields that are part of the data of that, and then also having a canonical constructor that also makes sure that all those fields are initialized. So also you want to model data, whole data, nothing but the data. And so you want to make sure that when you are comparing two objects, that they are ensuring there's equity between them. So for example, you want to make sure you can express the alternatives through like a sealed hierarchy. Again, refining all the potential differences for it, instead of having to define that just through documentation in the code, like Java.exe, like, oh, okay, we have multiple transaction types, but you don't. Sealed hierarchies allow you to express that in the code itself, saying like, hey, these are the different transaction types we might be working on within our class, or in this case, in presentations, there's like going to be a standard presentation or a workshop presentation. It's defined actually in the code, and not just through documentation or anything like that. Also, you would want to make sure that the implementation of equals and hash codes actually, achieve the goal of making sure that if two things are equal or represent being equal. So a good example of that could also be that if a record was to have a list or some sort of collection within it or array, by default, the behavior of that would check if the memory references for those arrays or lists or collections are equivalent, but that may not actually be a good way of determining equity between them. You would probably often want to check to see if the values within that list or array are actually equivalent. Because if you had two lists with all the same values in them, they may not have the same reference, but you would probably want to say that those two are equivalent. Maybe not, but you would just want to make sure that that is appropriately being handled within the equals to hash codes of a record or whatever objects you're doing. Records can make it easy to do aggregates of data. So there can often be a desire within Java to make just stringify data or make data very stringy. So for example, like an email address, I'm still using it as a string here, but I could also have a record that encapsulates that to say, and maybe it could have some sort of additional breaking down of like the domain and the user of that email address. But that way you can provide a bit more definition to the fields within your record or within your data objects, that it's not just a string, but a specific type of string. Also, you want to make sure that you have immutability in depth. This kind of gets back to, so if you have a list within a record or some sort of collection, you could, yes?
Does using records give any advantage in working with an ORM?
No, so right now, records aren't a good fit for ORMs because ORMs are expecting mutability to the data and records are immutable. So once you set the fields for a record, you can't actually update a field for it. So yeah, they're not a good fit. Now, if you're just doing some sort of a view with an ORM, it could kind of work there, but you can use it as an entity type. So you would also want to ensure immutability in depth. So briefly touched on before, records offer shallow mutability. So let's declare all the fields within that record as being final. But there might be some fields within that record that you might need to do some additional defensive behavior upon. So for example, within this attendee, I have a list of presentations. Like an attendee might say, hey, I want to make sure, I'm attending Bruce's and Ted's presentation and Zach's presentation. So like I go through and like favorite them all to make sure he might get like some sort of list back for that. But lists, if it's like an array list as the underlying implementation, that could be added and updated without changing the reference for it. So that would break the expected immutability of it. So for example, then instead of you would want to make a defensive copy of that and have that then be to some sort of an immutable list. So you would get that by default by using list.copyOf, which returns an unmodifiable list. Actually, and this is probably not correct. I can just return that list because that's when it changed for it. But that just ensures that you're not going to allow that data to change unexpectedly upon you. Really probably a good practice to follow even outside, even with other, even if you're just doing object-oriented programming, you usually want to make sure you perform some sort of defensive copy of it just to make sure something else that has a reference to that list can't unexpectedly change it on you without you expecting it. Another, I think, really good principle to follow that's essential to data-oriented programming, but would still be good for outside of it, is making a legal state unrepresentable. So whenever you have an instance of an object within your application, it should already be in a valid state, so that way you don't have to continually do validation checking on it throughout your application. So for example, of course, this would mean that within the canonical constructor, doing whatever sort of checking you would need to make sure that's in a valid state. So for example, I would want to make sure that, first name is not null, and it's also not blank. If it is either of those, with those exceptions, and with last name, also perhaps like for favorite presentations, maybe that can't be empty or something. You could do whatever appropriate checking you would want to make sure to do that. Or for example, again, maybe why I would have like a record email, I could do some checking on it to make sure that the email address is valid before it's actually created. That way I won't have to do any other validation throughout the system to make sure that the email is valid. So I think that's a great benefit. Again, something that's necessary within data-oriented programming, but also probably good practice even outside of it. Then you would also want to make sure that the behavior data should be separated from the modeling of it. And because a record is fully transparent, you have full access to its internal state, you don't need to co-locate operations within it, like sometimes you would in object-oriented programming, to do behavior on it. So for example, if I wanted to add a new favorite presentation to a attendee, I would separate it out into some other class that would then act upon it. Now, right now, this looks really, really ugly to update a record because it's immutable. You would need to copy the initial state and then do whatever update to it so you can return the next state of it, or the updated state of it. So this does not look good at all. I'll touch on it a little bit later, kind of like a bit of my opinion on, is it ready? Is data-oriented programming ready within Java? And maybe how that can actually improve in the future of it as well. That's it. Like, you can have some behavior as long as it's derivative of the contained state. So for example, if we wanted within like the attendees an ability to do like a pretty formatting of a name that says like taking like a first name, last name of the company, you know, you can just have an operation on that because you're not modifying the state of it. And sometimes it's just be nicer for a convenience of it to have that there. So when would you want to consider to using data-oriented programming? So some of the advantages and disadvantages. So this will work really well within ETL, exchange transform load operation, because oftentimes obviously you're doing immutable, you're taking data, transforming it into another one, and then you're sending it off. You're not really doing any transformation to that. It's also really great for very small scale systems, again, where you're often existing at a boundary of it, which again would often be a case for like a microservice or function. Actually, sorry, this is wrong. Data density, I mean, that was me incorrectly understanding some of the data-oriented programming. But of course, you know, for example, if you're doing a lot of data transformation, working with ORMs, that's not a good mix for data-oriented programming. Or if you're working with some sort of large-scale system like a monolith, which, you know, I've worked on plenty of times where you're doing a lot of changing the state within the system. Again, that is, broadly speaking, not a good fit for data-oriented programming. Now, there might be small subsystems within that monolith where you can still use data programming. It's not like, you know, when you're going in to design the systems, like everything has to be data programming or everything has to be object programming. They can exist within the same system together, you know, as long as they're following some good architectural principles. That's it. Like data-oriented programming, it's a bit more niche. It's not as generally applicable as object-oriented programming, but kind of like I said, you can also use DOP within a subsystem of a OOP application. That's at least my personal opinion. Kind of when playing with this a little bit, when I was first working on this presentation a while back, I wasn't fully there on data-oriented programming. Maybe it's a case of still maybe needing to work with it a bit more, finding some good examples on when to use it. Some of the value also maybe seems to be somewhat dependent upon like bad implementation of OOP or following bad principles of OOP. So it's kind of like, if you need to do that, like, yeah, it's like, if you follow bad principles or you follow bad architecture, then, you know, anything that follows like good architecture is going to look good by comparison. Also need some better definition, at least better definition within perhaps the Java area. That's it, as I already touched on a couple of times. Making illegal states unrepresentable and transparently modeling data are both extremely useful and I think are very applicable well outside of data-oriented programming. I know there's been so many times in my career before I became a developer relations person where I was stung so bad because some object I had an instance of, like, oh, I had a field that was null that shouldn't have been null at that point, but because at some previous point it got saved to being null, or there was some checking that wasn't done at some other point that stung me, and that was a lot of painful experience where if you make sure whenever that new instance of that object is created that you're making sure that it's valid at that time, that can greatly reduce the complexity of your system. And also transparently modeling data can also be very useful to where there's not a bunch of hidden states that you don't always have easy access to when working with an object. There is some trade-off to that because sometimes you can't always easily do that with a object hierarchy because that sometimes becomes hidden in the state of a superclass. So, it's a bit of a give and take, and if you do have some sort of deep object hierarchy for some reason, you might, then you might have to weigh the benefits of potentially having to do a lot of copy and paste and repeating it yourself in the child objects to kind of fully model it out without having to do it at the model object hierarchy. Some other maybe specific cases for using data-oriented programming, maybe some specific examples, is handling multi-return values. So like, let's just say you're working with some sort of external service. Obviously, in that many cases, there could be a variety of errors that could happen. So like right now, you would have it handling with maybe multiple try and catches, like maybe some sort of interrupt happens, maybe there's a timeout, or maybe there's an exception for every other, maybe general exception you're handling. So now you can maybe have an interface, a sealed interface where you have a bunch of different types, where you have maybe a successful response, interrupted, timeout, failure, whatever, of course, makes sense for maybe interacting with this external service. And then you could use have a switch case upon that for then how to handle that a bit more gracefully, a little bit also more legibly than having a bunch of different try catches for handling that kind of behavior. So kind of getting into the future data-oriented programming in Java. So right now, so I kind of, just to go back a little bit here. Yeah, so right now, if you wanted to do some sort of update to a record, that is very ugly. So like right here in this example, like someone is adding a new favorited presentation to their conference application. And because a record is immutable, then you must create a new instance of a record, copy over all the previous state, and then the updated state for that. And that just doesn't look good. So you can see here, it's very noisy and exhausting to look at. So one of the things is derived record creation or withers, where you can say, hey, here's an existing instance of it, and then using the with keyword, say, okay, update just these fields of it, and then give me back the result of that, which would be a lot easier to work with. So this JEP means JDK Enhancement Proposal. This is whenever there's a somewhat substantial change being made to JDK. This is a way of just elevating it. It's a bit on hold right now, and that's because we're trying to figure out a new thing called data carriers. So right now, there's a lot of constraints that come with records, and it's kind of like you can either do records and have it immutable and all that, or you have classes where you have a lot more flexibility. But there might be some place in between there where you would want to have more of a gradual transition, going from a record with all these restrictions and a normal class with none of them. And so that's a goal for data carriers, where you can say, hey, okay, I have 3 fields, like first name, last name, middle name, that I want to have follow all the things with the record, and then maybe this composed name that's going to be like some sort of derived state that I don't want that to really be part of a record. So this is all very speculative. This is like the specific keywords might change, but I could declare perhaps certain fields to be part of a component. This must be kind of like transparent. And so like that would have like certain requirements that they must be part of a canonical constructor. That means they must have like their instance defined on creation. That would be very helpful. And then also kind of some of the stuff that comes with this is also hopefully things like withers and things like that can also soon follow after that as well. Oh, sorry, I need to fix that. But yeah, if you want to read more about it, again, Brian Getz, the Chief Language Architect, he wrote a whole long thing kind of about this, kind of first explaining why they put withers a bit on hold, because they wanted to maybe better define some of this better, and then kind of laying out the visions for how these data carriers, which is just their placeholder name for right now, might work into the future. Some other stuff that's coming is Project Valhalla, which will be defining value classes and objects, which those used to be classes without identity. So like a good example of that could be like a date class, like today is April 9th. Like you wouldn't really necessarily need identity for that. Like it's kind of like a, single object or a single concept like 2. Like you wouldn't need multiple instances of like the number 2 within your application. You wouldn't need multiple instances of a specific date within your application as well. So by removing the need for identity for it, that can improve the density and just reduce some of the restrictions around it. One thing actually I was just recently learning about is, so another thing I was hoping to become with Project Valhalla is no restricting the value of classes. But it's not quite clear if we'll be able to do that because that's going to have some of the difficulty that is about being able to support backwards compatibility in Java and being able to remove the nullability within Java might not be super practical. Yeah, that's it. Yeah, any questions kind of then? So some more follow-up links. If you wanted to get some hands-on experience, maybe doing data-oriented programming. One of my other colleagues, Jose Palmar, and I, but more him, he put together a hands-on lab. In this case, it's about refactoring a application that's following object-oriented features into using data-oriented programming features. So if you kind of want to get like a little bit more hands-on experience doing that, you can do that. I would probably recommend, so he has a bunch of different steps within this. I would probably recommend starting here on step 1 because it kind of resolves some of like the bad OOP principles that were kind of happening, and at least it kind of going from an already properly designed application using OOP principles to a properly designed application using dot principles. And then let's see. Yeah, actually, I need to remove that link. And then also, as I mentioned, my colleague Nikolai, he put together an 8-part series where he kind of walks through all the different principles of data-oriented programming, and then again how that can be applied when using Java. Yes, are you good about that? Have a question or no? Okay. Yes.
Oh, so is there an ecosystem that data-oriented programs really taking off in kind of before Java here? I mean, out of the elephant room, bluntly, I'd expect Java's about the last language I'd expect to lead on this.
Yeah, I think Haskell was pretty good with it. Unfortunately, I don't really have much experience with Haskell. I mean, really very much the vast majority of my experience, deep programming experience, is in Java. Of course, like everyone else, I've also used JavaScript at various points of times, but I've also largely given up on trying to understand JavaScript because every time I thought I understood what was going on, I was reminded I had no idea what was going on. But yeah, Haskell, I think, is one of the ones that have kind of followed that. I think within the JVM world, Kotlin also, because like it already had like data classes, like it had like 2 different data classes, correct? It's been a minute since I last worked with Kotlin, so I think it already also had a lot of the data-oriented programming features already in it.
I did Scala and Gradle more than Kotlin, no idea.
Yeah, gotcha.
Thanks.
Yeah, absolutely. Any other questions regarding programming Java? Yeah, sorry, this is one of my quicker presentations, unfortunately.
Yeah, I have some questions if nobody else does.
Yeah, please.
Okay, so yes, Haskell was mentioned. I've spent a fair amount of time with Haskell, and yes, data-oriented programming is exactly what you do in Haskell. The record types are what Haskell would basically call a product type.
Yes.
And your sealed interfaces basically amount to sum types.
Yeah, exactly. Yep.
And what you're doing is you're pattern matching. Haskell has extensive pattern matching capability. And I would say because it was designed that way from day one, the syntax to accomplish it is a lot cleaner because they designed it to do that on day one.
Yeah.
It wasn't something that was where you tried to retrofit it in afterwards. But I have kind of experimented with trying to do Haskell-ish, I'll kind of put that in quotes, kind of things in Java. And what I really miss is, you're right about the immutability of data, because that's what really gains you things like thread safety.
Yeah.
And it makes your programs much easier to reason about if you know that you're passing some data structure into some method or function or whatever, and you know that it's not going to get modified as a result of passing it in. You're not going to have side effects and things like that. But the problem with trying to do this in Java is we don't seem to have a standardized, what I would call a persistent collections library.
Yeah.
That's agreed upon, because in your example you showed that records are only shallowly immutable. In fact, you might even want to back up to that slide. See, if you have a list as a field inside the record, that list could be modified if you don't take steps to protect it, like making a defensive copy or passing an unmodifiable view of that internal data structure. Now, I have been experimenting. I wrote a persistent list class, and it actually works very well, because see, one of the fundamental problems was when the collections API was first designed by who wrote Effective Java? Joshua Block.
Yeah.
Those optional mutating methods on collections to set an element, or to add an element to a list, or to remove an element to a list. If you look at that API, those are optional. Not all list implementations are guaranteed to implement those. And what that means is, remember the solid principles? He's violating the L.
Yeah.
The L is the Liskov substitution principle. You can't just put in any old list as a parameter and think that that's going to work, because the receiver of that list might try to mutate it, and oops, it wasn't implemented in that particular list implementation because it's optional, and it's supposed to throw an exception that says it wasn't implemented. Instead, what I think they should have done was there should have been, for the mutating methods, there should have just been 3 methods: insert, update, and delete. And what they do is they return a new version of the list. Okay, it doesn't mean a whole copy. They're not copying the whole thing, but maybe it's a version of it where that one element is put in, and then you can chain it.
Come back to, unfortunately, that case, it's like the backwards compatibility by if we were to, change the API of the collections framework, then it would require a whole lot of rewriting for a lot of applications and all that stuff. But
right. But it's possible to do it. It's possible to do it if you just implement the list interface and add those 3 methods, but then you make it a final class. Okay. And then whenever you write code, you say, I'm only going to take the persistent version. You see what I'm saying?
Mm-hmm.
And so anywhere you have methods that are going to be read only, you're fine. Just go ahead and pass those persistent lists in, and they're not going to call those methods anyway. And they'll throw an exception if they do.
Yeah.
And you'll be all right. And so the data structure that does that is called a hashed array mapped trie, or a HAMT, believe it or not. And there was a doctoral dissertation that was done on that years ago that apparently Josh Block knew about it. I asked him about it in a forum. And there has been some work at Oracle about it. I saw a Java 1 presentation in 2021 or something, where Oracle was experimenting with it, but then I heard nothing after that.
Yeah. I mean, that sometimes happens where, so actually a pretty good article, or not article, but if we go to YouTube, and so Nikolai did an interview recently, again, Brian Getz, and one of the things he was talking about where, you don't, so like oftentimes we don't maybe necessarily, or we maybe sort of experience it as just, developers just implementing our projects, where, like that first time you try to implement something, like once you have some experience, like, that was really wrong. But and then, so like maybe the second one's a bit better, but because the scope of what we're working on is so much larger than what's typically going to be the case for any other developer, because now our user base is millions of developers, trying to solve all these different issues. You have to go through many different iterations of it. So maybe probably what was happening, we maybe were looking at trying to implement something like that, and they maybe went through 3, 4, 5, 6, 7, 8 different implementations of it, and probably just eventually kind of realized it maybe wasn't necessarily workable. I know one thing also, so actually my colleague Nikolai, he was just in Kansas City earlier this week, and he also had a presentation he gave on data array programming. But at least one thing a question that came up was default values for methods and things like that. And one of the difficulties for that is that it has a issue with how overloading would also happen within methods within Java. And it's just kind of like, there's no easier, clean way to be able to cover all those different use cases that have already been explored without, having a huge potential issue with backwards compatibility. So I kind of suspect, at least, that was maybe being worked on in earnest, a few years ago, but it might have just been the case. It's kind of like, there's just no easy way to retrofit it, or at least they couldn't define a good way of retrofitting it without potentially having a huge potential negative impact on the existing code bases.
Okay. I see you have a video there down in the bottom right, Java serialization.
Yes.
I thought that was a mistake. That's a security hole, isn't it? Aren't we going to get rid of that?
Huh? Sorry?
Aren't we going to eventually get rid of serialization?
Yeah. That is a goal. And so in this case, what this is kind of, this is actually a video I did where I kind of explored the background of Java serialization, kind of like what the goals of it were. And then, of course, also a lot of the security issues, and then, of course, also how we're trying to work on fixing those issues as well. So if you've ever been stung by serialization or some of the offshoots that come from serialization, and kind of want to understand that a bit better, maybe give this video a watch, because I kind of go through all that stuff.
Right, because Joshua Block has an entire chapter about just don't use it.
Yeah,
It's a big old security hole a mile wide, and I just don't understand what they were thinking in the early days of Java, because I think the computer science people were actually telling them at the time not to do it, but they did it anyway.
Well, it was really important to the early success of Java because persistence is a really ugly thing where, again, I kind of go into that in this video. And because Java made it so easy to handle persistence, that was a big, big reason for its early adoption. So, you know, and also at the time, Java was new and upcoming, so it didn't necessarily have as much of a concern with some of those legacy issues.
Yeah, the security problems.
Yeah.
Yeah. Okay. Back to your data-oriented programming, though.
Mm-hmm.
Is there a way to do a destructuring assignment in Java outside of a pattern match?
Not right now. That is also one of the goals with data carriers is to have the ability, actually this, I think you actually, yeah. So within like ability to define a deconstruction within your data carrier class on how that class can be taken apart as well. I'm trying to think, does he have an example of that? But if you check out this link, I think he goes through an example of how to destructure. So not right now, outside of pattern matching is specifically only for record pattern matching, but that is hopefully going to be a goal here, or that's going to be a feature here at some point in the medium future.
Okay, yeah, because that's a very Haskell-ish thing to do.
Mm-hmm.
Is a destructuring assignment. You just assign it over. Well, what happens is Haskell has first-class tuples.
Yeah.
And which Java doesn't seem to have. You can kind of create them sort of with records.
Yeah.
But they're not really first-class citizens in the language. But
Yeah.
once they become first-class citizens, now you've got a product type.
Mm-hmm.
And you can just assign it over with tuple notation, and you've pulled all the fields out of your tuple, and you're good to go.
Yeah. So.
And that's a nice thing to be able to do.
Yeah, absolutely. So yeah, no, that's a goal that they're working on towards. And like I said, I'll make sure I send you this PDF, and then that way that can gives you easier access to.
Yeah, maybe you can send me a few of those links too, because I'd like to look at them.
Yeah, absolutely.
Okay, yeah. Well, those are my questions.
Yeah. Any other questions? Anyone else? Then?
Just
Yeah.
that question. Maybe preempt you.
No, I was saying no.
Okay. I'm just curious, like, from your vantage point within Oracle, are folks using DOP in any capacity, or is it mostly just like a language design type of exercise?
Within Oracle,
like, is there any sort of like guidance where we recommend this programming style or model for?
I don't think we, like I said, the most would be kind of like the like again what Nikolai put together here, like that's like the most quote unquote guidance, but that it's not something that for example, like the actual JDK engineers have like maybe put together an article really probably perhaps outlining in more practical terms on how to use data-oriented programming. So I think to me, just speaking my personal opinion, I think once the data carrier classes are added, I think that's going to make it a lot more practical. Like I said, just to me, again, just the updating a record, quote unquote, updating a record is just such a pain point that I think that really limits a lot of the practical applications. Like right now, it's like just at the margins of practical to use it. Like it's practical to use it if you're really keeping things immutable. Like you never needed to change the state of a record. In which case, again, like it would be great for like an ETL project or something like that. But yeah, there hasn't been, to my knowledge, anything more official than what Brian wrote or what Nikolai wrote here on official guidance on using data-oriented programming. All right, well, thank you everyone for coming out, and yeah.
All right, well, thank you, folks. Let's see, do we have any other announcements or things to go over, Bruce or Ted? Do you hear me?